सब्सक्राइब कीजिए फाउंडेशन गुरुकुल बाय आर के चैनल को और बेल आइकन को दबाइए लेटेस्ट एजुकेशनल वीडियोस सबसे पहले देखने के लिए।
Hello students, how are you? I am R.K. Jha, Faculty of Mathematics. We are going to learn today real numbers in chapter 1. In class 9, we have studied about real numbers, especially about irrational numbers. Now in class 10, we are going to continue our discussion on real numbers. We begin with two important results, Euclid's division algorithm and theorem of arithmetics. Euclid's division algorithm is concerned with the Euclid's division lemma. So there are two words that you are perhaps the unfamiliar, lemma and algorithm. So first we discuss about the lemma and algorithm. After then we shall continue on the topic fundamental arithmetic and division algorithm. Okay, let us start here. What is lemma? Lemma is a proven statement which is used to prove another statement. Lemma is a proven statement which is used to prove another statement. Actually, lemma is a short result and we need not to prove it as like theorems and theorems or corollary. But this is a statement like lemma, postulate, assumption, etc. So, for example, dividend equal to divisor into quotient plus remainder. We have learnt from our childhood that dividend equal to divisor into quotient plus remainder. That's a statement. You can say it formula or I can say it a statement. And this statement is an example of lemma. This is a short result and we need not to prove it like theorems. Okay. Next our topic is Euclid's division lemma. Euclid's division lemma. All you are familiar with Euclid's, who was a Greek mathematician and have written certain books named Elements, which has so many volumes, and this word lemma algorithm has been derived by Euclid's. So Euclid's division lemma, what it says in its lemma, division lemma, for any two given positive integers A and B, we say we get unique positive integers unique positive integers Q and R such that A equal to BQ plus R, where 0 is less or equal to R and R is less than B. This statement is the Euclid's division lemma. A equal to BQ plus R, where 0 is less or equal to R and R is less than B. So, if we have two integers, any two integers we have given, and if we divide the greater integer by the smaller integer, then we get two other integer Q and R, such that A equal to BQ plus R. A is the product of B and the Q, and when we add it in R, then we get the integer equivalent to A. We can learn it or understand it by this way. A is here dividend, B is divisor, Q is quotient, and R is remainder. So, A is dividend, B is divisor, R is quotient, Q is quotient, and R is remainder here. Now, we have to understand this statement. 0 is less or equal to R and R is less than B. This statement, A equal to BQ plus R, is just like the dividend equal to divisor into quotient plus remainder. Actually, we found that formula from this Euclid's division lemma in our earlier classes. Now, we have to understand this. Okay? So, first of all, reverse it and write it. So, after reversing and writing it, we get B is greater than R and R is greater or equal to 0. This one. Now, all we know that divisor is always greater than remainder, or remainder is always less than divisor. Otherwise, the division will not be accurate. So, remainder always less than divisor. Next thing is remainder will be either 0 or greater than 0. If number divides completely, then we get the remainder as 0. And if it does not divides completely, then we get a number in the remainder column. So here R is greater or equal to 0. Okay. Here we learn about the Euclid's division lemma by these questions, a few questions solving in the example. First question is divide 117 by 13 once, and after then you again divide 117 by 14 and write in the form of division lemma. So just look at this. We divide here 117 takes as dividend, and now we have divisor 13, and we get the quotient. On dividing 117 by 13, we get the quotient 9. So we get here remainder as 0. So we can write it as 117 equal to 13 into 9 divisor into quotient plus 0 equal to 13 into 9. Here we see that remainder is 0. Next, 117 by 14. Then we get the quotient 8 and remainder 5. So 5 is less than 14. Also the 0 is less than 13, less or equal to 0. Remainder is less or equal to 0 and less than b. So b is greater than remainder. Here also b, this is b, and b is greater than r, or r is less than b. This one you can say b, this is a, this one is q, and this one is r. So we can write it 117 equal to 14 into 8 plus 5, this one. We shall use the division lemma, Euclid's division lemma, into Euclid's division algorithm. It has a good use in algorithm. Okay, now our second example question. Here we see the second example question. A number when divided by 73. There is a number, unknown number, and when it is divided by 73 gives 34 as quotient. Its quotient is 34, we get the quotient 34 and remainder 23. Find the number. So here in solution, let the number be A. Let the number be A. Here B equal to, B means divisor, divided by 73. 73 is our divisor. So here B equal to 73. Q equal to 34 and R equal to 23. Using Euclid's division lemma, we get A equal to 73 into 34 plus 23 equal to 2482 plus 23 equal to 25053, 32582 10 0 carry 1 4 1. Okay, correct. Therefore the required number is 2505. Thus we have in this class learned about the definition of lemma and Euclid's division lemma. But in the next coming classes we shall learn about the Euclid's division algorithm, and after then we shall see how we apply the division lemma and division algorithm for solving various types of mathematics questions. Okay, thank you. Now you take homework for today, exercise 1A, question 1 to 3 from R.S. Agrawal. Okay.